All right. Unannounced live. So, live.
has come through on a trajectory in the opposite direction and has arrived at its closest point to the sun when the Earth was on the wrong side for us to conveniently observe. But Mars was on the correct side of the sun, and our Mars assets were able to observe the comet, and also several of our other spacecraft were on the correct side of the sun. So the scientific community is really excited about the comet and about these new observations. I'm tremendously excited to help share them with you today. This is a new scientific opportunity, and it's a new window into the makeups and histories of other solar systems.
It's been a lot of BS.
We're just beginning to learn about these types of objects and figure out what are the right questions we should ask about them. Now, let me start by going directly to what we were able to see at the beginning of September, when Psyche was able to see the mission. So before that, though, in August, we organized a workshop. We organized a coordination session for the missions across the NASA fleet that had good opportunities for potentially observing 3iAtlas, so that we could all share observing plans and knew what was going to be possible with our assets.
They've been doing a lot of PR.
I can't emphasize enough now how, thanks to the cooperation of so many mission teams, we will be accumulating a wealth of data on this comet that the science community will be digging into for years. Now, let's go back to September, and I can show you a sample of the images collected by our different mission teams.
Okay, here we have an image.
To set the context, you're going to see a comet. It's a small body with a coma around it, basically a fuzzy blob. Now remember, space is big. Nothing is ever really as close as you like, and all of these observations are very, very difficult. It's a little bit as if our NASA spacecraft were at a baseball game, watching the game from different places in the stadium. Everybody's got a camera, and they're trying to get a picture of the ball, and nobody has a perfect view, and everybody has a different camera. Now, let's return to September and see the first images from the Psyche spacecraft. NASA's Psyche mission acquired 4 broadband black and white images of the comet over the course of 8 hours on September 8th and 9th, 2025. The comet was about 33 million miles from the spacecraft at that time, and you can see in the image the large frame.
Welcome everybody.
The comet was seen at different times.
Live
down
stream
in the bottom
about
left is a blow up, a stack in addition of all of those observations.
Hoping they actually release new images.
On its way to an asteroid in the main asteroid belt that's also named Psyche. And these images were the first captured from this perspective.
They showed one image a few minutes
ago.
Now,
if you think in that lower left, you're not seeing very much, just wait a minute, you'll see more. Now, the following week in September, the Lucy spacecraft observed the comet from the opposite direction. So let's take a look at the Lucy image. This is another broadband black and white image made by adding up a series of individual exposures that were taken on September 16th. Lucy is on its way to study asteroids that shared Jupiter's orbit around the sun, called the Trojan asteroids. Lucy was 240 million miles away from 3iAtlas, which is circled in the center, when its high-resolution LORRI camera caught the comet. You can see the comet's coma, the fuzzy halo of gas and dust surrounding 3iAtlas, and its tail, a smudge extending to the right of the comet. If you were the Lucy spacecraft looking at the comet from this angle, the sun would be a little bit over your left shoulder, and so the comet tail is pointing away from the sun, as we've seen many times before.
So here they're trying to address the fact that it had no tail for
scale. This image spans about 1/3 the width of the full moon, as you'd see it on the sky.
Which was one of the anomalies.
At the distance of the comet, that's a much, much larger region of space than the moon. Now, this looks a little different from the Psyche image. Part of that is because the cameras are different, and part is because of the ways the Psyche and the Lucy teams decided to show their images. But also, it's because we're seeing the comet from different directions. Seeing a comet's coma in different lighting geometries, with the sun coming from different directions, is one of the key ways to learn about the physical properties of the dust that's been launched off its surface. And I want to emphasize that you do not get these views unless you have spacecraft farther from the sun than the comet is so that you can see it backlit. We could not get this view from the vantage point of the Earth.
Let's see, are they going to address the 12 anomalies?
Combining the data from Lucy, Psyche, and Earth-based telescopes, scientists are hoping to better understand.
They already claim that they have like 12 different
the comet
telescopes looking at this thing.
It's a rare opportunity to compare ancient dust from a distant solar system to that from our own. Now let's go to the next picture from the MAVEN spacecraft at Mars. At the beginning of October, 3iAtlas passed within 20 million miles of Mars, which gave our Mars spacecraft an opportunity for a close-up. Earlier, you saw the image that Ahmed shared from our Mars Reconnaissance Orbiter. MAVEN is another Mars orbiter that has been studying the Martian atmosphere since 2014. Now, this picture is not a direct picture of the comet itself. It's a spectrum. You're seeing the science wiggles that Sean was just talking about. This is some of those science wiggles where the instrument, the spectrograph, the ultraviolet spectrograph on MAVEN has looked at the comet and also split up the ultraviolet light according to color. So you're seeing three different bands in this image. On the right, you're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's a fainter band indicating that's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from comet 3iAtlas. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet,
the comet is there.
No little blob on the left side of the image. But it's also telling us it's one of the many ways that we're able to discern the chemical composition of 3iAtlas. And in this particular example, it's showing us
talk about the nickel then.
That's coming off of the nucleus. Now, MAVEN's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate. How much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy.
All right, let's hear it.
Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3iAtlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the sun. Comet 3iAtlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent
found to be unusually bright.
This image highlights the value of spacecraft and instruments designed
Can we talk about the anomaly?
Directly toward the sun, as Nikki was saying before, not only to study the sun, but also to have the ability to see other objects crossing, in this case, behind the sun from the telescope's point of view.
Okay, we're going to hold out hope that
you'll be able to see the rest of the images on our 3iAtlas website, go.nasa.gov/3i-atlas.
I'm going to go.
And there will be more to come. Not all of the data have been downlinked yet through NASA's Deep Space Network, and there are more observations still in work. And also, it's a long way from where we are today, seeing the initial images, to then making sure that they're accurately calibrated and processed to do science with. And then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. But the answers will come later on.
Answers will come later, people. You can't have answers.
Very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. This is a snapshot of where we are very early in the scientific process.
Very early.
Okay, back to you.
2 months in, very early.
Thank you all for your opening remarks. We'll go ahead and start the question and answer portion of this event. Just a reminder to our media on the phone bridge to press *1 to enter the queue and ask your questions. We'll take our first question from the phone bridge from Marcia Dunn with the Associated Press.
Yes, hi. Based on your latest observations, what more can you tell us about the potential shape of the comet can you fine tune any more on how big or small it might be?
Yeah,
Origin,
tell us something. Good question.
All that sort of thing. Thank you.
What does it look like?
Thanks for that question. There's a lot of territory to cover there.
The
So let's
pictures
see
were
what I
so
can do.
pathetic.
The size
One
of
new
the
picture,
nucleus
Aaron.
still has yet to be pinned down. The best data are
They still don't know the size. Oh my
the
God.
observations that Sean was talking about. So we're still
Avi
right
Loeb
now
said
in
until
that
they have the
range of
mass, they
somewhere
cannot
in the
calculate anything
vicinity
else.
of
The acceleration,
a couple of thousand
brightness.
feet to a couple of miles diameter, but we'll get
Couple
better on
miles
that.
in diameter. That's what they're sticking with.
The shape of the nucleus is also difficult to pin down because generally
Difficult
we're
to
not
pin down.
resolving it in our observations. It's obscured by the dust, and especially it's obscured by the reflected sunlight off of the dust in the inner part of the coma. But what observers from the ground have been able to do is observe the brightness of the center of the comet over time.
Okay, somebody asked me to pause it. So I'm going to pause it if you don't care about not being totally in sync with the live. Just to update people on what's going on. I started watching it from the beginning. It started out with, you know, them immediately saying, we embrace open science, but, you know, but we're sure this is a comet, and we just want to dispel any rumors about it not being a comet. And what I found interesting too is they have this panel of experts, and the panel of experts look like they are hostages. They are all looking so unhappy. They're frowning. And then they even had the first guy talk about how this is so exciting, but like he had no affect on his face. He never looked excited. He looked like he was lying. They got people reading from teleprompters. They're saying one thing and shaking their head the other way. These are just some, you know, things I'm noticing about their body language. They put up one picture from October 2nd, which was very blurry. I mean, it just looked like a blob. There was nothing. It was not nearly as good as the pictures we've seen from the amateur astronomers, which is crazy. They made sure we knew that it's not a danger to us. And they made excuses about how it's hard to see. And they were bragging about their capabilities and how many telescopes they listed, like I don't know, 15 different telescopes that are all trained on 3iAtlas. And they talk about how they're going to make all the images available to the public 24 hours a day, although we haven't seen that. So that's my little update. And then we're going to unpause the live stream
to see if there's a modulation of that brightness that would be an indication of rotation. And it's very difficult to discern. So what it's looking like so far is that there's not a big, the shape of the nucleus is not very far from being round. Doesn't seem to be a big, or at least we're not seeing signatures of a very elongated object yet. There's a lot still to come there. I think you were also talking about origin.
He's addressing the absence of a tail.
Great. It would be fabulous if we could trace back the incoming trajectory into the solar system and trace that back and figure out where it came from.
We've had 2 months.
But things are not quite so simple. Our galaxy, as Sean knows, is a big and complicated place, and the sun and all the other stars in our galaxy are in orbit around the center of the galaxy. And so 3iAtlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in to our solar system, that it came from some very old population, of solar system around a very old star. Quite possibly, we can't say this for sure, but the likelihood is it came from a solar system older than our own solar system itself, which gives me goosebumps to think about, frankly, because that means the 3iAtlas is not just a window into another solar system. It's a window into the deep past, and so deep
at least looks a little excited.
That it predates even the formation of our Earth and our sun.
It's very exciting. We should be excited.
All right, we'll take our next question from the phone bridge from Bill
population?
Harwood with
I didn't
CBS.
hear that. Okay, next question.
Bill, if you're talking, we can't hear you.
Tell me again. This is Bill Harwood again. Can you hear me?
We have you loud and clear.
Okay, thanks. Sorry about that. You know, I mentioned the rumors that were, you know, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have 2 questions for anybody who would care to answer. One is, did any of you seriously, did you take seriously the proposition from some that this could be an alien spacecraft? I doubt you did, but I'm asking the question anyway. And number two, is there any evidence you see in any of the data you have that would fit an explanation like that? Or as far as you're concerned, does all of this data say conclusively that this is simply a comet that happens to be passing through the solar system? Thanks.
So I'll take that one, Bill, and thanks for the question. We love all of the different science and all of the different kind of hypotheses into what these things can be. You know, when you start seeing something, you just got a point. You know, it's natural to wonder what it is. And we actually love, as Amit said, we love that the world wondered along with us. And that's such a cool thing. We certainly were able, because of the measurements that Sean described from the astrophysics telescopes that immediately turned on this object once we found it. And even, you know, I was interested, I just learned that we'd actually gone back and actually seen it before we even found it. So that was super cool. I just heard that from Sean. But, you know, we were very quickly able to look for sort of, you know, the easiest thing to do, I'll put it in a different way, is if you understand comets pretty well and you understand asteroids pretty well, you kind of know the signatures that you're looking for. And so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, you know, Tom, I know if I throw this to him in a second, he's going to geek out about it. But the really cool thing about this is the differences, because it comes from somewhere else. And that's why we're so excited about it. It's only the third time that we've been able to identify and track something coming from outside our own solar system. We've long predicted these things occur. And now, of course, we know better how to look for them, and we now have this amazing Atlas array. You know, we're expecting we'll find a lot more of them, but it was quick. We were quick to be able to say, yep, it definitely behaves like a comet. We certainly haven't seen any techno signatures or anything from it that would lead us to believe it was anything other than a comet. But the super cool thing is
that's the only thing you're looking for.
It's exactly like all the comets that we see in our solar system. It's the differences that are so tantalizing for us as we and you know, it gives me goosebumps too. It could be from something that existed before our own solar system. That is so cool. It's from something that predates even our own star. Yep, it's going to look different because it didn't come from our solar system, and that's what makes it so magical. You want to geek out a little?
Okay, I just have to stop and say something. So she didn't answer the question, right? The question was, are you seriously considering the possibility that it is alien? And all she had to say about that was, well, we didn't see any tech signatures, as if that's the only way to know that something is possibly not a comet. So it's not just the question of, is it alien? It's the question of, do you have any other hypotheses besides comet, right? That's the only hypothesis they put forward. And they're not addressing the fact that there's a lot of data that does not support that hypothesis. Okay, that's what I have to say about that. And let's get back to it.
A little bit, Tom.
You were geeking out so expertly, Nikki, to begin with. So that was fabulous. But that's exactly right. I mean, things from other places, we naturally expect them to be different from our own homegrown variety. And I like to imagine if you're fortunate enough to have grown up in Hawaii and you only drank Kona coffee, you love your Kona coffee, and then somebody says to you, well, gee, have you tried Sumatran? You're going to say, well, do you expect it to be different? And they'll say, why don't you try this? And you try it and you say, wow, that's really different. And you realize, well, I expected this to be different because it was from someplace else. It was a different environment in Sumatra. Now, does that one sip of coffee tell you everything about the weather in Sumatra and the soil?
2 months of sips.
People who harvest the coffee, bless them. Of course not, but it's different, and yet it's still coffee. And that's what we have in this case. We have a cometary body. It behaves, it resembles the homegrown
We're not idiots.
that we have in our solar system, and yet it's excitingly different in particular ways. It does the same thing comets do. It evaporates carbon dioxide gas. It evaporates water, but it's evaporating more carbon dioxide compared to water. So that's a very interesting thing.
That's an anomaly.
Comets evaporate dust, and the dust is broken down. The minerals are broken down by the ultraviolet light of the sun. And comets, we know comets put out nickel, they put out iron. That's what comets do. This particular one is putting out more nickel than iron. That's really interesting, really remarkable, and something to be studied in the future. So
Okay, we got to address that. So they're like brushing over. They're brushing over the anomalies, right? They're like touching on them, but they're not addressing them. So he just brushed over the fact that it's putting out this thing called nickel. I think it's carbonate. It's a particular nickel. Now I'm forgetting the word, but it's like a molecular compound that combines nickel with something else. And there's no iron in it. And they have absolutely no data anywhere at any time in the whole history of space exploration of ever seeing nickel without iron. They've never seen it. And the only time they've ever seen this particular type of nickel molecular, chemical compound is in industrial production. And he just didn't address it. So I'm going to get back to the live stream, but I just had to address that. So we're just looking for, are they addressing the, it's making me start over. Are they addressing the,
we're always interested in new ideas. We're always interested in new suggestions. And
are they addressing the anomalies?
Ideas are good when they're born, but those that stand the test of time, those that stand up to testing, those that are supported by the evidence are the ones that survive.
All right, we'll take our next question on the phone bridge. And that one comes from Matthew Glasser with ABC.
Good afternoon. Thank you for doing this. Tom mentioned that the answers will come in time. I'm curious about what are some of the hopes that we might discover from this comet. What might it tell us about our planet, about our solar system, about the universe? Are there key things you're looking for as you start to analyze this data? And are you excited about anything in particular when it comes to better understanding how things are working out there?
Sure, I can take that. Every new object we discover is a new piece in the puzzle.
Most of the anomalies.
What we're trying to do always is to understand the universe. That's part of the NASA mission, is to understand the solar system, understand the universe, understand the origin of planets, the origin of life. And that is a huge question. And we get little bits, little clues to parts of that puzzle, and we start trying to put that puzzle together. We have gained tremendous amount of information from hundreds of years of astronomical observation and from decades of in situ spacecraft observation has revealed our planets as actual places, not just points in the sky that you could barely see with your own eyes. We've learned about comets and asteroids, and we're beginning to put together a picture of how all of those planet-forming minerals and planet-forming ices came together to form our planets, and how our solar system changed over time. Just one example, we get a fascinating clue from the objects like Pluto that we've been discovering since the 1990s, the trans-Neptunian objects. The way they are distributed through space in the outer solar system show us clues to how the orbits of the major planets may have changed over time in the early.
Okay, I just have to stop for a minute again and call BS, because why is he talking about Pluto? Why is he talking? This is a live stream about 3iAtlas. This is a hugely popular topic that a lot of people are interested in, and everybody wants to see images, and we're not seeing the images. And people want to know about the anomalies. People want to know about the size, the speed. What's the chemical composition? We got questions. There's no answers. I'm just saying, I'm frustrated. I was really hoping they were going to address some stuff. Maybe they still will. It's early. Okay, let's maybe stay hopeful.
Solar system, a fascinating thing, and questions that we would never have thought to ask before we knew about these trans-Neptunian objects. Now, interstellar objects, like I said before, are new windows, and it's windows that we've never even looked out of before. So what we're going to find is way too early to predict, but I think we're getting a hint of the breadth, the wide spectrum of conditions that existed in different parts of the galaxy, in different solar systems, where the compositions, the elemental abundances, the mineral abundances may have been very, very different. It would be a different picture if we were seeing the first 3 interstellar objects and we'd say, gee, those look exactly like our homegrown comets. That would have been really interesting, and we would have said, well, maybe our galaxy is a boring place because every place is the same. What we're seeing with this is not every place is the same. That's a good thing. Lots of places to explore, and they will be different if we ever manage to get there.
Yeah, I think of these as frozen fossils from their moments of formation, including the things in and now from beyond our solar system. Or in some cases, we point our telescopes at other debris disks, which is just, a whole system full of these small bodies. And so now what this will let us do is tell that story in a broader context between the detailed and large library of data we have on those origins of our own solar system, and how volatiles were delivered to make life possible here on Earth, combined with that big picture of other systems, of the dust spread throughout those other solar systems. And now with this visitor that got frozen in time from somewhere beyond our solar system,
Visitor is right.
Small picture of what that was like when that formed.
And the fact that I love the sort of thought of it as that frozen fossil, almost frozen time capsule. We're kind of privileged. I mean, it's come into our solar system, our sun. We know, we think it hasn't seen a star for a long time. So it's actually warming up and giving us more information. It isn't just about a frozen object coming through and us sort of saying, oh, look, there's a frozen object moving through. But as it's almost waking up and showing us its composition.
We're the ones
that's
waking up
allowing
over
us
here
to be able to do this great science. If it had just remained frozen all the time, we wouldn't know much about it. But it is the sort of its rendezvous with our star that is allowing us to really do this amazing science. And that to me it makes me feel almost privileged to actually be able to unlock the secrets as this cometary object is coming around and rendezvousing and interacting with our solar system.
All right, let's head over to social media. Nina on X asks, will it hit any planets in our solar system?
No, it will not. I think if you, obviously we're not going to run it again, but please, go online, take a look at go.nasa.gov/3i-Atlas and take a look at the trajectory. I kind of talked through it briefly. Tom talked through it, and you can sort of see where those planets are. And remember this, even though it's exciting and it's coming through, space is huge, as both Sean and Tom talked about. And so the probability of it actually hitting anything is super, super small. You have to have all these things aligned to actually be able to do it. But
all right, let's just pause there. Yeah, so there are some people who are worried about it hitting Earth or hitting something. And, I had conversations with 3iAtlas, and no, they're not planning to hit anything or invade anything. They are collecting data on various planets. They are interacting with lots of planets from what I've been told. So they're now addressing that fear.
Certainly the objects in our solar system will be just fine.
And we have another question from social media from Astronomeum. They ask, what makes Comet 3iAtlas so different and intriguing compared to the other interstellar comets?
Tom, you want to take that?
The other interstellar objects. We say interstellar objects because not all of them were comets. So the first one was discovered in 2017. That was 1I Oumuamua that behaved very much like an asteroid. Again, a little bit like 3iAtlas, a very interesting asteroid, and so it was different from the asteroids we're accustomed to seeing in our solar system. For one thing, it was seemed to be very, very elongated, and while it was inactive, it seemed to be an inert, mostly rocky object. It did show indirect indications that it was evaporating gases in some way. It wasn't around long enough for us to get really, really comprehensive long-duration observations and understand exactly what it was doing. It was the very first one. We saw it for a short time when it was on its way out, in fact, and so we didn't get a great view of that. The second object, 2I Borisov, discovered in 2019, behaved, it was a comet. It was definitely a comet. It behaved in a lot of ways like our homegrown solar system comets, in many ways like 3iAtlas. Its properties were more in line with what we're used to seeing, and the comet observers regarded it as very much akin to our solar system comets, although in some ways a little bit at the edge of what we're used to seeing. 3iAtlas is in a lot of ways like 2I Borisov, but a bit more out there in terms of things like the carbon dioxide to water ratio.
Except 1,000 times bigger.
All right, Svetlana on LinkedIn asks, will the observational data from this campaign be available for open analysis?
Absolutely. Every piece of NASA data, we are delighted to share. We've had open data policy at NASA for a long time. We make a big effort not just to release the data, but also to make sure it's usable.
Can someone confirm that by going to that website?
To analyze the data as well, and we invite everybody to look at this comet with us. If you're able to take your own images through like citizen science programs, we love that too. We love everybody to be sharing in the joy of NASA science as we take every opportunity to take advantage of these incredible visitors to our solar system.
And that citizen science campaign, that includes work that citizens help us do to identify small bodies in our solar system. And so if you really want to get engaged beyond just looking at the data, you can help us generate new data and find other objects for us to study.
Yep, the big one.
Yeah, let's see some pictures, people.
SOHO, big comet
pictures.
finder, big comet tracker. So many of those comets discovered by our
46 minutes in.
So keep those observations
pictures
coming.
All right, we'll head back over to the phone bridge. Our next question comes from Ken Chang with the New York Times.
Hi, thank you. This is for Tom and Nikki. One of the measurements made so far, what is uniquely different about this comet, other than the trajectory, of course? And two, since perihelion, it looks like there are multiple jets. I was wondering if you could talk about that and the speculation that it might have exploded. Thank you.
Go ahead.
Yeah, thanks, Ken. So some of the differences I already mentioned is the ratio, the carbon dioxide to water ratio, the nickel to iron ratio. Also, there were ground-based observations noting that the polarization of the light reflected off the dust was also unusual. So that's telling us some interesting things about the dust. There are other indications that the physical properties of this dust, maybe the grain size distribution, might be different from the sorts of things that we're used to. The appearance of a sunward tail early on in the trajectory was part of that, an indication that the dust was being pushed off the comet on the sunward side, and then it took a while for the solar radiation pressure to push it back the other way. That's been seen before in other comets, but not very often. I'm sorry, Ken, what was the second part of the question?
Did it?
Perihelion.
Jets. Yeah. The jets, right. So seeing more activity are in the inner coma around the nucleus right around the time of perihelion, when it's being warmed most intensely, is something that happens frequently. That's something the comet observers are going to be very, very excited about. It does take some time to figure out, because it takes time for the actual event that happens on the surface to propagate out to a distance where you can see it with a telescope. But people are going to be mapping what jets there are. It doesn't necessarily mean there was an explosion. Jets can also just mean there are particularly active areas on the surface of the comet where more volatile stuff is evaporating in that one spot than elsewhere and jetting out. We saw this a decade ago with the ESA Rosetta mission at Comet 67P. It got up close and personal with the nucleus and saw frequently that there were jets coming out from specific places on the nucleus of the comet. So that could very well be what's going on here. Can't tell for sure, but that's the sort of thing we've seen before.
The other thing I just want to say that we're expecting to see as more stuff gets thrown off this comet in these jets is at those warmer temperatures, additional things can bake off of it, additional gases can bake off. And so we do expect the composition of the coma to potentially change, or those jets to change over time. And looking at the details of what other molecules we detect beyond the carbon dioxide and water we mentioned is also going to be interesting, especially for that sort of like, what was this stuff? What was the area in this, what was this stuff made of in the area it was made, like long time ago?
Our next question is from David Chandler with Sky and Telescope.
Yes, a couple of things. Have you any of these observations showing you anything about any non-gravitational accelerations at this point? And also, can you say a little bit about coming attractions? What observations are in the pipeline that have been made but not released yet? I think the MRO high-rise observations, has that been released yet? And what else is there that's either in the can and waiting to come out, or observations that will be made over the coming weeks as the object comes closer to
another
Earth?
anomaly?
I can answer some of that about the non-gravitational accelerations. This is something that we look very closely at for every comet, because that's always something that happens. And just to back up to explain what the question is that as comets evaporate, they are blowing off gas, they are blowing off dust, and every time something gets pushed off the comet, that acts like a little rocket engine at that moment and pushes in the other direction. And so it's very, very common to see comets have subtle changes in their orbits as a result of these little rocket forces, just called non-gravitational accelerations. So this is being monitored very closely. I spoke to our orbit determination team of the Jet Propulsion Laboratory earlier this week, and what they said is that this is being monitored. There are some changes to the orbit, but the uncertainties are still fairly large. It's difficult because we can't see the nucleus directly. It's difficult to get a very, very precise track on exactly where it's going. But so far, the non-gravitational accelerations have been very much on par with the sort that we see in solar system comets.
In terms of future observations, this is a situation where, because this is only the third time we've had an opportunity to look at an object like this, everyone that is in control of a telescope wants to look at it because it's a fascinating and rare opportunity. I know that our colleagues from the Keck Observatory have looked at it. I believe that we're going to look at it again with JWST in December. We have some other ground-based facilities that are giving us additional compositional information as those additional molecules bake off of 3iAtlas. Those are the things I'm aware of. There's probably a lot more that I'm not, because like I said, like every astronomer wants to get data on this thing because it's such a rare opportunity.
Yeah, and the high-rise image that you asked about specifically, Amit kind of rolled that out at the beginning. So please take a look at that image.
One image.
I think Sean is
not going to show it again
a lot on what these astrophysics telescope. I don't know why, but because we are able to look at it in infrared with the James Webb Space Telescope, that will be the last time we can see the comet. So as it is exiting the solar system and getting further and further away, the James Webb Space Telescope will actually be able to track it longer than anyone else, partly because of its ability to kind of look long and deep rather than sort of across and wide, and the fact that it looks in the ultraviolet, in the infrared, so it can kind of see the dark objects. And so I'm really excited about just sort of, tracking it to the very end. Also noted, we're downlinking data from missions. I mentioned Parker Solar Probe because I just heard before we came on that we'd got some data and we'd seen the comet. I haven't had time to look at the data yet, but all of those things are coming up as we are getting more and more data coming down to us from those missions. And then as both Sean and Tom talked about, just really making sure we're sharpening up those images and really, making sure they're calibrated. Right now, we're putting out almost the raw images. We're putting out things quickly so everyone can see them, but we'll take some time.
No, you aren't.
Real sort of deep looking into those and do some more of the spectroscopy. Tom showed a really great example of kind of looking through the atmosphere of Mars, taking...
Right. Spectroscopy. For some reason, I always have a hard time saying that word, but it's one of the ways that astrophysicists, take pictures of distant bodies, and it involves looking at the chemical composition by looking at the wavelengths of color. That's a simplistic explanation, and they only showed one spectrographic photo in this entire live, just one, and it was just about hydrogen. Where are the rest? I'm just saying, there's a lot of data. Where's the data? Okay, that's my rant.
Take out that hydrogen, take out the hydrogen from our solar system, and then let us look at the hydrogen that's coming from the comet. So we'll be doing a lot more of that as we move on to do great things with NASA science.
Great things,
All right, that's a great lead into our next question on social media. Elijah on X asks, what kind of processing were the images subjected to, and why did they need it?
That's such a basic astronomy 101 question.
The images that were released received the sort of standard processing that we do between the raw data that comes down into a telescope. That, as Nikki said, we need to make sure for scientific accuracy that they're calibrated against the other observations, and we account for anything that the telescope is doing in that moment. And so that it would be our standard set of calibrations and normalizations for a object of this type, which is to say,
where are the images?
I can add a little bit more to that. As Nikki said, our desire was to get these images out to the public as quickly as possible. And so there are some image artifacts in there that you'll see. And I can specifically, I can speak to
That's a funny
the
comment.
Lucy image that you saw previously. If you look at the comet, you'll see some blobs around the comet. Little blobs, faint blobs around the comet are not real. It came from the fact that in order to get this particular view, it was necessary, which is this backlit view, the team had to turn the spacecraft to face more toward the sun than it generally does. And so that means some part of the spacecraft were in the sun, and some of that bright, the sunlight reflected off parts of the spacecraft got into the camera, and that resulted in those little blobs. So that's an example of processing that has yet to be done to figure out exactly what that scattered light contribution was and remove that from the image, so that what we show in the image is entirely what was there in the sky and not.
I got to interrupt this again just for a minute, just to say something, just for some context. Typically, they would process this data within a few days. If it was something really important like this, it would be only a few days. They've had 2 months. They got this data on October 3rd. It is now November 19th. Okay, it's not 2 months yet. Well, let's say 6 weeks. They've had 6 weeks to process this data. And they're telling us for the last hour in this live stream that they are going to process this data one day, but they haven't had time yet in 6 weeks to process any of the high-rise data. High-rise is supposed to be producing the very best images that we expect to see of 3iAtlas, because it did a flyby right over Mars, and so it's a lot closer than our Earth telescopes, and they're expecting to have really good images from high-rise. All they have shown us in this live stream at the top of the hour was one blurry image. It wasn't as good as any of the amateur astrophotographers. It was one blurry image. Now they're talking about how they process, data. And that is important. But you know who does a great job of talking about that is Stephen Burns, if you follow him. He did a video the other day where he talked about how you have to take multiple images and stack them in order to actually get a really good picture. All right, back to the show.
Something just made by sun glints off the spacecraft hardware.
Yeah, and sometimes I think you showed the Soho image where we actually stacked a couple of images, because a single image, you wouldn't be able to see it. It would be too faint. But if we stack a couple of images together, then you can actually start to really make out what that comet looks like.
Okay, next, Gail on Facebook asks, how can an object like 3iAtlas come from so far, moving as fast as it is, and not hit anything?
Orbital dynamics. And space is really, really huge, and so
empty.
It is amazing to think about just how big even our solar system. And so to give you the Voyager spacecraft, Voyager 1 is now 1 light day away from Earth, which means when we send a command or we send a photon from Earth, it takes a full day for that photon to arrive at Voyager, and Voyager is only just outside kind of what we think of as the edge of our solar system. And so space is vast. Yes, this thing is moving quickly, and yes, it came from outside our solar system. But the probability
big and
of it
fast. These are
hitting
two
something
anomalies.
is so small. As everything has to align. It's also not quite in the ecliptic plane. It's not quite in like our normal, if you think about sort of looking side on at our solar system with the sun, and then you put
that's
the planets
another
kind of
anomaly.
in a row.
It is very close.
Normally everything sort of orbits in this plane. This is slightly tipped, not unusual because it's not gravitationally bound to our sun, but it's slightly tipped. That makes the probability of it hitting it almost even greater.
If I can play with a scale model solar, if you make a scale model solar system where the sun and the Earth are 1 foot apart, that's about 1 foot. The sun is a P. The Earth, you need a magnifying glass to see, it's so small. The entire solar system will just barely fit in your house if you squeeze a little bit, and the next nearest star is over 50 miles away. So they call it space for a reason. Most of it is space.
Okay, we'll head back to our phone bridge. Our next question is from Brandon Spector with Live Science.
Okay, so they're just
Hi,
taking
I wanted to
questions.
ask
People who
about
just
the
got here.
age of the comet. You mentioned there's circumstantial evidence that it's much older than our solar system, but how can we constrain that age a little more? And what will that tell us if it is indeed much, much older than the solar system?
I can start that, but I'm going to pass it to Sean to talk about ages in the galaxy.
Okay.
So, so cutting to the end, the bottom line is going to be, it's probably going to be really hard to get a more precise figure from one object. I think what we're looking at in the future, as we discover more of these, when we get to the point where we have maybe a few dozen of them and look at the distribution and properties, we may be able to get a better handle on what the distribution of ages is. So what's going on here is that it takes the sun 240 million years to orbit around the center of the galaxy, and we're doing that with a neighborhood of stars. So we're all going around the center of the galaxy. The relative motions between stars in our solar neighborhood is sort of 10-ish, 15, and sorry, I have all these numbers in my head in metric because that's the way I learned them, but 10 or 15-ish kilometers per second. So what is that? That's about 25,000 miles an hour, I think. And 3iAtlas is coming through at a speed of 60-something kilometers per second. So that's 3 times faster than the average of our local neighborhood.
Third anomaly.
Which is telling us that it's coming from a different population from what we have generally around us. Now, Sean will be able to clarify the age dispersion relation in our galaxy, which tells us, which has been discovered over the last century studying stars in the galaxy, that the relative speeds of stars is an indicator of age. Stars that formed older in our galaxy over time increase their random motions for reasons that Sean will explain. And so that's the circumstantial evidence that makes us think that 3iAtlas came from a solar system that had larger motions relative to our solar neighborhood and is older. But it is a circumstantial and probabilistic argument.
So I'm just going to take this opportunity to brag about our telescopes and the James Webb Space Telescope in particular.
Go for it.
This blows my mind. We have data from galaxies closer to the origin of the universe than we have data from rocks closer to the origin of Earth, right? In other words, like if you pick up the oldest rock that we have from Earth, it is further away from the origin of Earth in terms of hundreds of millions of years than the amount of time there was between the origin of the universe and the earliest galaxies that JWST has now observed. And that's part of this story of how well we understand not just the history of our home planet, but the history of the entire universe that it's a part of. And now this is just another part of that story of the local neighborhood that our solar system is a part of.
All right, our last question for today comes from X and asks if we can see grains of sand on Mars. How is the clearest photo we can see for 3iAtlas, what we've seen?
So because we're closer to the grains of sands on Mars, right? And so the JWST can only get like these single pixel blobs of the faintest galaxies, the furthest away galaxies in our universe. And because 3iAtlas is in our solar system, we can get the images and the compositional information with JWST. As it got closer to some of the planetary spacecraft Tom was talking about, they can't even see these galaxies, but because 3iAtlas was closer to them than they were to JW, they got really good images of the object as it passed by.
Right, as you said, we can image individual grains on Mars because we have spacecraft standing on Mars.
Right.
But even our closest spacecraft to 3iAtlas, we're still 19 million miles away.
And it's going too fast for us to send something there to intercept and get that close to it. So that's just not that we just don't have the. If we could. We would, we would be there up close and getting those grains.
All right. Well,
okay, I think they're telling on themselves right there, because that was a unsolicited excuse, right? Where they're like, well, if we could send a probe to measure this, we would. It's not clear that they couldn't. I have heard some people talking about the possibility of them sending something to at least go through kind of the coma to maybe pick up some data from the dust and the gas that's around it. They could certainly have sent something through that. So why didn't they? And why did he bring that up randomly? So I'm just super suspicious now. I may sound super paranoid, but I am, because of the way they're not addressing the anomalies, the way they're not showing us images. I just find it very strange. There are 12 anomalies, which I've been putting into the chat over and over again and onto the screen. And they kind of mentioned a few of them, but they didn't give any real explanations of those anomalies or, and a lot of them, they just didn't mention at all. So I just think that's very suspicious. And just the absence of images. They should be putting up tons of images. This live stream was actually called, we're going to show you the images, and they're not showing us the images. Why?
Well, that's all the time we have for today. Thank you so much for joining us. Be sure to follow along with NASA as we continue to observe 3iAtlas. Find new images, detailed information, and resources by visiting go.nasa.gov/3i-atlas and by following NASA Solar System on social media. Thanks for joining.
Okay. Well, thanks everyone for joining my my impromptu live stream. I was all excited about the NASA live stream, and so I had it on my calendar and I scheduled my day around it. And I was like, oh yeah, we're gonna see some new images. We've all been waiting for new images, right? So like those of us who've been following 3iAtlas for the last month. That was fun. That was more fun than their whole live stream. So right, like we were all excited. So for the last month or so, I've been following all the images coming out. I've been following different astrophysicists, astronomers, geophysicists, and listening to what they have to say. I've also been tuning into the comet. See, now they got me saying comet, the object, the interstellar object as well, and getting image intuitively. And I have been following Avi Loeb and his analysis of all the anomalies. And so I was really looking forward to at least seeing some images. I also did suspect that if they didn't want us to know anything about this, they were going to continue to withhold. And so for me, this is one of like the biggest pieces of evidence that this is not a regular comet or even an unusual interstellar comet, because if it was, they would just share the data like they always do. And so for those who don't know, and I've been learning this from people I've been following, that they typically have like a public stream of data. They typically release and process data within like a week of it being picked up, especially when it's something hugely important like this. And so for them to go 6 weeks without sharing anything, and then now here we are a week out from the government shutdown being over, and we're still only seeing 2 images. We saw 2 images today that were not already out there. One was from October 3rd. They showed a blurry image. And I'm going to have to go back and take a screenshot of it so I can talk about it, show it to you again later. But they took one blurry image from the Mars reconnaissance rover. I'm forgetting the full name of it. Mars. Anyway, the HiRISE. Right, the HiRISE. We've all been waiting for the HiRISE images because they are like supposed to be 3 times as more detailed as anything we've been able to take so far with any of the other telescopes. And so we've all been waiting for those. They showed only 1 image from the HiRISE in this live stream, and it was a blurry blob. That was it. It was blurrier than like most of the other images we've seen from amateur astronomers, from astronomers in other countries. I just feel like that is evidence that this is more than a comet, because why aren't they talking about it? Why aren't they sharing the data? Why did they just waste our time with an hour of talking heads, not addressing the 12 anomalies, not showing us any images? Why? Why would you do that? Like, that's not good for NASA. I mean, it's not good branding, right? If they want people to support NASA, it makes sense for them to share data and talk about, oh, we got all this new data and we're just, all this money that, taxpayers are paying for all these fancy telescopes is being used. And we're actually taking all these amazing pictures. And let's compare it to what they normally do, right? We've seen amazing Hubble pictures, right? I know you all have seen the amazing Hubble, and they've been coming out for years. They're always liking to show off the amazing pictures that the Hubble telescope can take. In fact, during the shutdown, they were putting out images from the Mars high rise of other things. So clearly they weren't all the way shut down. They were able to release images, but just chose not to release images of 3iAtlas. So yeah, I'm a little on a rant right now. I'm hyped up because I was really looking forward to seeing some new images. And also they had the second image that they showed on the live stream was a I need to learn how to say that because for some reason I can't remember how to say spectrographic image. But basically, these are two ways that they collect data in astrophysics. They do astrophotography, where they take pictures using telescopes, and which is, relying on the same things that regular photographs rely on, light. But then, well, am I wrong about that? Someone correct me, because it's been a while since I've been involved in. I did astrophysics as an undergrad. That was many, many years ago. But anyway, I think of it as like a camera, right? It's different. It's a different process, but then spectroscopy is where they look at the chemical composition of the object. And they had one image, one spectrographic image, and it was of the hydrogen level. But they didn't actually discuss the absence of water. So early on, one of the anomalies was that it only had 4% water. And they found that out by using this spectrographic analysis, where they looked at the wavelengths, at the chemical composition of the comet object, and they found no water, virtually no water. Comets are supposedly made of water. So then they were like, well, maybe this comet is made out of carbon dioxide. But it's an anomaly because, well, I can't remember exactly, but I think it's because they've either never seen that, or it's really rare, or they've never seen it in the size. Anyway, it's something that is not easily explained. So these are what anomalies are. Anomalies are things that, data that does not fit the hypothesis that needs to be explained. And so in some cases, it will be explainable, right? But if so, they should explain it. And they didn't even try, which I found strange. They were defensive. They did mention some of the anomalies, but not my name. They never said, we're going to address the anomalies. They never said, yes, there is this weird anomaly. They never used that word. That seemed very intentional. But also, whenever they did bring up an anomaly, they would say, oh, yeah, well, the size is really large. But they wouldn't address how that's an anomaly, that they've never seen anything this big moving this fast. Like, that's an anomaly. Why can't you just say that? We've never seen this. And maybe in the future, we'll be able to explain it. They didn't even say that. So I just found this whole live stream very sus for that reason, because of all the things they did not say, and because of all that they did not show. The whole live stream was supposed to be about us finally seeing images from the high rise, and we did not get to see them. We saw one image, one blurry image. Why would you spend an hour and only show two images? There was another image they showed, but it was an image that was an old image. So no one's looking for old images. We already have the old images. They only showed one from October 2nd, and that's the time period that we're really interested in, because that's when 3iAtlas was flying really close to Mars. Really, I mean, it's in relative terms, closer than it was flying to Earth or to anything else where we had a camera. So that was like the best position for us to get the best images, was when it flew by Mars. And because we had like 4 different telescopes on Mars. I think European Space Agency has one. We have a couple. She named a couple of them. One was the Mars Reconnaissance. Then there was the Mars High Rise. I tried to write them down, but I didn't get them all down. Someone can put it in the comments if you know. So let me look at your comments and see if I want to respond to, if there's anything that anyone wants me to respond to. Yeah, so like Jenny T says, it's what they did not say and how nervous they looked. So I also was looking at the body language, and I'm not a body language expert. That's not a field of expertise I have. I do watch body language videos. So I feel like I know a little bit. Sometimes a little bit is dangerous, right? But we're all humans too. We're all humans in relationships, and we all have intuition, and we know how people come across to us, right? And these people did not come across as truly excited about this. And they came across as nervous. They came across as, I thought they looked like hostages when they first showed the panel. Nobody's smiling. you know, there's zero affect. When the first guy was talking, he's talking, but he's like got no facial expressions. I found that odd. That's not proof of anything. That's just my impression. Okay. Oh, I did not notice. Someone said that. Oh, wait, wrong one. Someone said that the chat was full of clowns. You mean the emoji clowns? I didn't. I couldn't see the chat because it was so small. I couldn't see the chat. I wanted to see it. I was at first. I had two live streams going. I was trying to watch both, but I got overwhelmed because then I wanted to look at your comments. Yeah, so this was, yeah, I agree with you, Jay. I also thought it was weird when he said, we will know more when we see more of these things. Wait, this is only the third we've detected. How many more of these do you think are going to fly through? So this is another anomaly we can discuss. That's, you know, the size and speed of this was considered anomalous because we've only seen 2 other interstellar objects, and they were, one of them was 1,000,000 times smaller, and the other one was 1,000 times smaller than 3iAtlas. And so one of the things that I think it was Avi Loeb said was, you know, we've had the technology to observe this type of object for only 10 years. So we've had 10 years and we've only seen 3. And he said it didn't it wasn't probable. I was trying to use a different word. Probabilistically. I don't know why I'm getting tongue-tied today. It's unlikely that we would see these really small ones and then this ginormous one. And I think he said that we should only expect to see something this big every 10,000 years. So why is that? Why didn't we should have seen like a dozen at least other ones before this one. So that was another, I think, anomaly, the size and the speed and the fact that, you know, we've never seen anything like this. So I don't know. They talked about, oh, when we see other ones, but they didn't actually say this is an anomaly. We wouldn't expect to have seen something this big after only seeing small things for the last 10 years. Like they didn't address that anomaly. So again, it's what was missing that's suspicious. The missing images, the missing analysis, the missing response to anomalies. They were super, super committed to insisting this was a comet, but they weren't actually providing data to support that hypothesis, nor were they addressing the data that disconfirms the hypothesis of a comet. Yeah. Why? Right, Shannon? Why are they not mentioning any of the anomalies? I mean, they did mention some of them, not by name. They didn't call them anomalies, but they did. And while it was streaming, I was putting up the anomalies and trying to make sure you understood that they were touching on them, but they weren't really addressing them. So like they mentioned, what did they say? They mentioned, like they showed this spectrographic image of hydrogen. And I felt like that was their way of addressing the anomaly of, if this is a comet, why is it only 4% water? Water is H2O, right? So I think they were trying to address that anomaly in a roundabout way by saying, oh, look at all the hydrogen we found. But they weren't able to actually address, and they did mention, oh, it's made of carbon dioxide, but they didn't actually say how bizarre that is. And they didn't address the fact that comets are defined. At the beginning, they defined a comet as basically an icy rock, a cube of ice traveling through space. Ice is made of water. But then, you know, because this is one of the anomalies, I keep putting the anomalies into the chat. I'll put them in again, just to remind us. So one of the anomalies is, oh, I got an error. They don't like the fact that I keep pasting the same thing, I guess. Okay, so, right. So here are some of the anomalies that were identified by Avi Loeb and other scientists. Its retrograde trajectory aligned within 5 degrees of the ecliptic plane of our planets. The fact that it had a sunward jet instead of a regular cometary tail. In fact, it didn't have a tail at all for many months. So now some people are saying, oh, the reason it didn't have a tail is because it was flying towards our cameras, and so we couldn't see the tail. So that's a possible explanation. And that's what we should expect. We should expect with each of these anomalies that scientists should provide explanations or possible explanations, right? And then, of course, it's going to take more, data analysis to actually be able to explain these anomalies. But I felt like they didn't even really try that hard to provide any analysis of the anomalies. They wouldn't even name the anomalies or admit there were anomalies. They didn't even consider the possibility that maybe it's not a comet, or that maybe they don't know what it is. And that's really all I'm expecting. I'm not expecting NASA to come out and say, this was an alien spaceship, they're coming to, take over, right? I don't believe that either. But I was expecting science, right? I was expecting like the scientific inquiry. I was expecting them to say, we think it's a comet because it has certain features of a comet, but we're aware that it also has a lot of anomalies which are not features of comets. And so we're going to continue to do more research and to analyze the data and to try to understand whether this is an interstellar comet, as we suspect, or maybe it's something that we've just never seen before and we don't really know what to call it yet, right? Like, I think that would have been a more honest answer, and an answer which I think had more integrity. Like, just admit what you don't know. It's okay if we don't know. Like, that's what science is about, right? Okay. Oh, here's some information from somebody. So TESS, SPEAR, and SWIFT were the other telescopes outside of JWS and HiRISE. Okay. Yeah, I got some of that list. I got Webb, Hubble. We got the Webb, the Hubble, the SWIFT, the Perseverance, the Mass Reconnaissance, the another one, MAVE, Psyche, Stereo, ESA. There were a whole bunch that they listed. So many telescopes that should be collecting data. So, I love that, Shannon. A drinking game every time the word comet was said. Oh, yeah. Yeah. So Sid from Planet Earth. There's also a lot of people in the science community that don't like admitting we don't know everything. And that's, that is part of the problem. And so let me just talk a little bit about that as it relates to what I was told by 3iAtlas. They did tell me that what part of what they're doing by showing up in our sky at this time is they are creating a scientific revolution. And they're doing that because they said they were delivering a lot of data to our scientists, which they're not going to be able to make sense of. And it's going to force them to question their standard model. It's going to force them to question their stellar models, their, all of their cosmological models, their astrophysical models. Their laws of physics are in question right now. And they're in a tizzy right now because they're really uncomfortable with this type of situation where what they think are as kind of immutable laws and truths that will never change are up in the air now. And they can't accept that. Some people can't accept it. And some people are just in shock or confused. And people are afraid to risk their reputation by saying, hey, the laws of physics don't apply to this object. Therefore, maybe the laws of physics need to be changed, right? That's a major Galileo type movement, right? Scientific paradigm shift. And people are not comfortable with that. And so that's what my intuitive merging with 3iAtlas told me, that this was one of the things that was going to happen. They did tell me that the reason I am suspicious of NASA too, just to be honest, is because I spoke to 3iAtlas, and 3iAtlas said the scientists know we're not a comet. They know, they have enough data to know this is not a comet. So I do think they have enough data to know it's not a comet. And I do think that if they didn't, that they wouldn't have come across this way. if they felt really confident that it was a comet and that the data supported that hypothesis, why didn't they come across as confident? Why didn't they come across as, oh yeah, this is a really interesting interstellar comet. It's very different from comets we're familiar with, and that's why it has some features that we don't recognize. They did say that, but then they didn't go on to say, for example, it doesn't have water, even though it's a comet, and it has some non-gravitational acceleration. They did try to address that by saying, oh, it's got these, spouts of debris, shooting off of it, causing it to have this gravitational acceleration. But when Avi Loeb did the calculations, he said that the mass wasn't large enough to explain the acceleration. Now, we really don't know the mass. So that was an interesting thing that came out of this live stream too, was very early on, they were asked the question, what is the size and shape of this comet? And they said, we don't know. They said one estimate was that it was a few miles across. That's the size of Manhattan statement, right? We've been hearing that for a while, that it might be the size of Manhattan. But other calculations, recent calculations, have suggested that it might be more like 25 kilometers apart or something like that. So there's been different estimations of the size, and what they did admit in this live stream was that they don't know what the size is. Well, if you don't know the size, you can't really make calculations of things like non-gravitational acceleration or brightness. Like, you can't really come to conclusions about any of that if you don't know the size. And I find it really strange that they don't know the size after 2 months of collecting data, really more than 2 months. They've been collecting data since July. So after all of that data, all of those images, they're not able to calculate the mass of this thing. That's very strange, because they've been able to calculate the mass of other objects. Why can't they calculate the mass? It's like the most basic thing that we need to know in order to calculate everything else is the mass, right? The mass and the speed that it's traveling at. So they do have the speed, supposedly. So so Shannon said that 3iAtlas told her the same thing, or them the same thing, that I'm assuming you're referring to 3iAtlas saying, they know we're not a comet. Oh, okay. Someone's got some intel about the chat. Medusa. So oh, that's not it. Oh, wrong one. Sorry. I'm going to come back to that. No, that's not it. Oh, it's going so fast that I can't keep up with it. So Medusa said something about the chat, and now I can't find it. Oh, here it is. Oh, here it is. Okay. Just reviewed the NASA chat, and this is Wood Thrush. And everyone was going crazy that they were not showing the pics. Oh, that's good to know. So it's not just us over here. Like, read the room, people. Read the room. The only people tuning into your live stream are people who actually want to see images, and who actually want to hear about the anomalies, and who actually want to hear about what's exciting and different about this object. Why are you trying to make it sound just like every other comment, just a little bit different because, it's not from here? Like, why not address its unique properties? That's what people want to know about, right? Okay, there was something else I wanted to read. Okay, so Medusa says, since we have never actually explored the universe, personally, speculation is used. Yes, I agree. So here's a little, voice of reason here. Right? Yeah, speculation. So my area, when I was in physics, I was in, my undergrad. I did my undergrad in physics, and I worked also at the linear accelerator for a couple of years. And I also did lots of internships at different labs. And I was in cosmology. So that's theoretical astrophysics. So it's not based on data. It's based on theories, right? And the theories are also informed by data, but it's not the same as like, experimental astronomy, where you're just looking at the data. So theoretical physicists like Avi Loeb, theorize things and it's not the same as speculation. I'm a philosopher, so words matter. Speculation has a different meaning in philosophy. Well, it has a meaning in philosophy, and then it has a common meaning. Like when we talk about speculation and common speech, we're usually saying, oh, that person has no facts. They're just making stuff up, right? That's how we kind of use that word. We're just speculating, spitballing, throwing stuff out, see what hits. That's not exactly what speculating means in philosophy, and it's also not the same as what happens in theoretical physics. They actually do their theorization based on math. So a lot of it's just based on calculations. This is why we need to know the math, right? How can we do our calculations? Oh, okay. Uh-oh. Someone else was looking at comments on the AP feed. Said the comments were dumb. Dumb in what way? So Shannon's got a lot of info. Said that Atlas said that they gave the people in charge a signal. So I was told something similar. I should probably introduce myself. I just assume everyone here knows me. You probably do, but my dad's always on my case about introducing myself. So I am Dr. Jennifer Lisa Vest. I am a psychic medium, a medical intuitive, a mystic, and I also have a background in astrophysics and philosophy. I'm a former academic. I used to be a philosophy professor, and I did my first degree in physics, and I've worked in some labs. And so I'm interested in all of these things. I'm interested in intuitive information, empirical information. I'm interested in logic. I'm interested in bringing all these forms of knowledge together. And I got the clear kind of message over a month ago that I needed to start talking about 3iAtlas. So I've been following, reading the preprints, following what other astrophysicists are saying. I've also been tuning in energetically and getting information directly from 3iAtlas. I've also got information from my guides, my star family, and I've also communicated with the sun. And what I like to do is compare what I pick up intuitively with what is being observed. So I'm always looking for, is there any verification of what I've been picking up intuitively? And so this is why, so this comment here that Shannon made, so it sounds like Shannon is also an intuitive, and they picked up that 3iAtlas was sending a signal. Now, what I got that's related to that, not exactly the same, was I got they were sending music. That, kind of like that movie. What's that movie? Close Encounters of the Third Kind, right? Remember the spaceship when it arrived, it was playing musical tones, kind of as a universal language. And that's what they told me, that they were going to send songs to the scientists so that they would know that this is not a comet. They were going to send songs. So one of the things that was said in the live stream related to this early on, one of the spokespersons said, this is a comet. We're just going to address the rumors right off the bat. We have found no evidence that this is not a comet. Now that was patently false, I think, because the anomalies all contradict until they're explained, right? And they might be, but until they're explained, they currently contradict the hypothesis of a comet. So that was, I think, a patently false statement, but they said it because they said, we just want to dispel the rumor that this is an alien craft. And the reason they gave for that, the two reasons they gave, which I thought were both problematic, correct me if you think I'm wrong. One, they said, we have no data that suggests it's not a comet. And two, we've gotten no techno signatures. I think that was the word they used. And I don't exactly know what that word means, but I think it's when they're looking for any kind of signs that they would expect to see from a spacecraft that like our spacecraft, which I think is not a really good thing to look for, because why would their spacecraft be like our spacecraft when we're so backwards that we can't even leave our solar system? And if they're leaving their solar system and coming to ours, they're obviously going to have much more advanced technology. And so what would a techno signature look like to us? Do we have any idea? For example, let me give you an example that you might think is out there. I've had lots of encounters in my, kind of mystical experiences with star beings. And one of the things, I have these guides, and I have all of these guides. Some of them are from other places. Some of them are from here. Some of them are angels. Some of them are dead people that used to be in my family. I have different types of guides. And there's one type of guide I have, which is from other planets, star beings, right? I'm a starseed. And what I was told at one point when I was channeling one of these beings, this was many years ago, I was shown how travel happens in the universe. And it happens by folding space. So they don't like have some big dirty combustible engine or any kind of thrusters. They don't have an engine because they don't travel through space. They fold space. So if there's a spaceship at point A and they want to be at point B, they don't traverse from A to B. They fold space so that B meets A and then they're at B. And that's how it was shown to me. So there's probably, and then there's, of course, like if you watch Star Trek, I'm a Trekkie, there's traveling through wormholes and black holes, right? There's all these possibilities for travel if we get past our own understanding of travel, right? So we don't really know, right? Again, we don't know how they're traveling. So we're looking for signatures. What kind of signatures, what kind of text signatures are we looking for? So I found that inadequate. I found that to be an inadequate justification for their very quick conclusion that this is very clearly a comet and not technological or alien in any way. And I just think that's bad science. So that's been my position from the beginning is, my understanding of the scientific method, what I was taught, decades ago. Admittedly, I've been out of the field for a while, but I don't think the scientific method has changed. I think other things have changed, right? But I don't think the scientific method has changed. And the scientific method is a way that you go about collecting data, making hypotheses, collecting data to support your hypothesis, then coming up with a theory, and then having it, tested, having it be repeatable, having it be repeated in other people's labs, having other physicists be able to come to the same conclusions, doing their own calculations or their own experiments, right? This is the scientific method. And so in the scientific method, and this is one of the things I specialized in. So because when I was an undergrad, I did my degree in physics, but I also did it in philosophy of science. I had like a double major. And so I was constantly, reading about and analyzing philosophy of science. Now, I also did a postdoc in philosophy of science at UCLA after I finished my PhD. So I do have a reasonable amount of experience in philosophy of science. And I can tell you that, that's just not how theories are developed. You don't just come up with a hypothesis based on past data. Oh, everything we've seen so far is a comet, so this is a comet. Like that's not how science is done. You might start with that hypothesis. Well, simplest explanation, right, is usually the best. We've seen lots of comets that look like this, so this is probably a comet. That's reasonable. We're going to assume it's a comet. We're going to start out with that assumption that this is a comet. But if the data contradicts that assumption, then we got to consider other possibilities, right? That's how science works. It's like, oh, we thought it was a comet because it had properties A, B, and C of comets. And that's true. It does have some cometary properties, right? So we thought it was a comet. But then we picked up all this other data, 12 anomalies now, 12 sets of kind of anomalous data, which do not fit our hypothesis of it being a comet. So now we have to consider other possibilities. That's how science is done. Also, we have to share the data with all of the other scientists so that everybody can analyze the same photographs, the same data, and then everyone's going to come up with their own conclusion, and then we're going to compare notes, right? That's not happening either because they're not releasing the data. So maybe they released it today. Somebody tell me if they released the data. In the live stream, they said they are releasing the data, but in the live stream itself, they did not release data. They released only 2 photographs in 1 hour. But they said they are going to release it. So if they do release it, what's going to happen next is that all of the scientists all over the world who are interested in this are going to be able to do their own calculations and, analyze the photographs and the spectrographs and come to their own conclusions. And then they're going to, publish papers, and they're going to have conferences, and that's what's going to happen. But it hasn't really happened yet because we haven't had the data. But yes, you're right. I agree with you, Lady Venus. And maybe we'll end on this note. The scientists need to be psychics and seers as well. I agree. I think, and that's the future. I am working on my own school, Metatron's Academy of Psychic and Science, where we're going to combine, different academic fields with different psychic fields, psychic healing, mystic, star seeds, all of these different other sources of knowledge. And this is, I think, the future, right? The future is that we need to look at all of these different sources of knowledge. We can't be narrow-minded. We can't be saying, oh, it's only I'm convinced it's a UFO and I won't accept any data that contradicts my belief that it's a UFO, or I believe it's a comet and I won't accept any data that contradicts that it's a comet, right? We can't be that way. We need to be open to all of the data. And if there are a group of psychics who have all remote viewed this and they're all saying the same thing, then we should take that seriously, right? Just like we want to take seriously the astronomers and the astrophotographers who have all picking up the same data in their telescopes, right? Okay, now let me stop and do the things I'm supposed to do as a YouTuber. Ask you to like, subscribe. Please subscribe to my channel. Thank you to everyone who already subscribes. Thank you to everybody who comes to my live streams. Thank you to everyone who comments on a regular basis. I really appreciate this community. I want to thank everybody who also has joined my Patreon, or if you've become a member of my channel, thank you. I want to thank everyone who sends me super chats and super thanks. These are just different ways you can donate to me through YouTube. And then some people have been sending me donations to my Venmo, and my Venmo is just the same as my channel name, Jennifer Lisa Vest. Anyway, I just appreciate all of you. I also have buy a coffee. Oh, I forgot to put that on here. I forgot about that. If you want to buy me a coffee, I can never point to this. If you want to buy me a coffee, there's a URL. No, not a URL, a QR code that will allow you to buy me a coffee. And so thank you to everyone who already bought me a coffee at my last live stream. I really appreciate it. So thanks everyone for coming. If I see another question, I'll answer it, but I don't think I'm seeing any more questions. Oh, hey, there's some pictures. They released the photos, high res. No high res. No, I was all excited. I thought it said high resolution. No high resolution pictures. Oh, why, people? Why? We have questions. We want to know, where are the pictures? Why aren't they releasing it? Okay, but it's okay, because just this person is just pointing out, where is that comment? I want to highlight this very positive comment. Where was it? Yes, here we go. Obia. Yes, people like me make me hopeful. Oh, that's funny. I was going to say people like us. People, okay, Obia, you're funny. People like us, like, look at the people coming to the stream, going to Dabsonian Power stream. I think Angry Astronaut also had a live stream. Look at the people who were in the NASA chat. Look at the people, right? People, from what we've heard in the various chats, there's a lot of really curious people out there who are open-minded, who are willing to consider different possibilities, who are following the news, who are following the astronomers, who are looking at the images. And this is a sign of our shift, right? This is a sign of our shift in consciousness, that we're like open to the possibility of being visited by people from other solar systems, that we're open to the possibility of there being life elsewhere. This is a sign of our evolving consciousness, that we're beginning to think this way. And so I think this is really good. And thank you very much, Shannon, for the 1999 super sticker. I appreciate it. Yeah, this is a really good sign of where we're at. And I just want to remind people of what my guide said about this 3iAtlas, what the significance of it is. They said that it's a sign. It's going to bring about a scientific revolution. And this scientific revolution is just one part of several revolutions that are going on right now, which are helping us to evolve and to raise our consciousness as a planet. So we have a scientific revolution going on in astrophysics right now because of 3iAtlas. We have a political revolution going on in the United States and in lots of other countries because of our political situation. And we have a spiritual revolution going on with the 4 a.m. Club and the Dreaming Women and all of the people who kind of got activated around the time of the election last year. And like me, I'm one of the people that I've been doing, psychic work, mediumship, medical intuition for years. That's not new. But following the election, my guides were very clear that I needed to start making my presence known on these different platforms and coming on here and talking about the spiritual significance of our political situation so that I can help people to navigate difficult times, stay hopeful, raise their vibration, and also just help us to evolve to the next level. And there's a lot of us who've been given these kind of marching orders. And so there's this kind of mass awakening happening. There are all of these women that woke up at 4 a.m. on the night after the election in the United States who had a very clear intuitive sense of what had happened, that it had been finagled and that there had been some manipulation and that the outcome was not the accurate outcome, right? So there's this awakening happening, and it's very exciting. It's very exciting what we're going through. Jonica Powell, thank you for the $4.99 donation, and you're welcome. Thank you for being here. I appreciate all of you. So these are very exciting times we live in, and we all chose to incarnate right now because of these exciting times. So when it starts to get to you, how crazy things are, how chaotic, at times how sad, just remember that you incarnated at this time because you knew that you had a particular contribution to make to this madness. There's something you came to contribute. And because you could have incarnated after the madness was over, like in a couple of years when things have, when things are going to be really great, because we're going to have not only torn down the problematic structures, but built new, better ones. That would have been a good time to incarnate, right? But you didn't choose to do that. You chose to come now. So now is also giving us all a chance to kind of think about that and reflect on, oh, what is my purpose? Why am I here? What are my unique gifts? What do I have to contribute? We all have something, right? Some of us are speakers. Some of us are writers. Some of us are bakers. Some of us are artists. Some of us are good at organizing people. Some of us are healers, right? We all have gifts and we all have something to contribute. And it's right now is the time for all of us to think about, what did we come here to contribute? Thank you, Shannon. We appreciate you, and this feels more like a gathering of friends you have cultivated. I hope so. It does feel like a community to me. I hope that one day, I've actually been talking about this to other dreaming women for many, many months. I hope that one day we have a big gathering, a big conference. I think, Gia is also interested in it. A number of other people I've talked to are interested in doing it. We were talking about it about 6 months ago, back when we thought this would all be over sooner than later. And we're still talking about it. So one day, maybe we'll have a nice gathering we can celebrate and actually see each other in person. Okay. Oh, this is the question. I see a question. I'm just looking at something else. Okay. Ms. Saftig J. I want to know if 3iAtlas is going to be amused that the populace is more aligned to a visit than the scientists. They know that, of course, because what they're doing is they're communicating with the scientists because they're trying to bring about this kind of scientific shift in consciousness. But they're also communicating with a whole lot of intuitives and remote viewers and, light workers. And so they are aware that there are different groups of people who are more enlightened or more open-minded than other groups. But they're also aware that it can't just be us fringe dwellers, right? Like, I can be on here all day, but I'm not a mainstream thought leader, right? I'm not somebody in a position of power. And so while I am having an influence on, you know, probably tens or hundreds of thousands of people in my audiences, there are people like Avi Loeb or people at NASA who have the potential to have a much bigger impact on a larger audience. And so, of course, they understand that if they can communicate with thought leaders and government leaders and different people in these kind of positions, that they have the ability to influence more people. Like that live stream we just saw, that was a wonderful opportunity for them that they just threw away. They could have taken that opportunity to really educate people about the scientific method, about how anomalies work. They could have talked about the possibility of alien life and what it would require scientifically to prove. Like there were so many things they could have talked about that would have been would have resonated with the audience, but they're not where we are. I do think we are turning into the majority. And so that, you know, that shift has happened. And we see that whenever they do polls on these subjects, like when you ask people, do you believe in psychic stuff? It's now the majority of people polled say yes. When people ask, do you believe in life after death? The majority say yes. Do you believe in ghosts? The majority say yes. Do you believe in healing beyond the mainstream medicine? The majority say yes. So this is where we're at, right? Globally, the majority has progressed past the kind of scientific mainstream or the medical mainstream. And so, yes, I do think that 3iAtlas and any other, you know, beings out there is aware of our situation. In fact, to be honest, I've been told, because I'm involved with this group that's like, it's kind of like the Galactic Federation, although I think it has a different name, but it's like, it's a group of beings that are from different star systems, and they get together and they have meetings. And I've been to those meetings, and they do talk about Earth, and they talk about how Earth is really kind of backwards and like pre-conscious, and how we're warlike. We haven't evolved past violence. And so that puts us, like, there's kind of a classification of civilizations or planets that exists out there. And the ones that have not evolved past violence or war are at a certain stage of development. And that's where we are. And so we can't really join the Galactic Federation or the Galactic Alliance or whatever it's called fully. Because it's like if you want to join the UN or you want to join NATO, you have to agree to certain things. And one of the things you have to agree to is that, you know, you can't study war no more. No one believes in war in other stellar systems. They don't believe in war. They don't believe in violence. They don't believe in rape. They don't believe in poverty. They don't believe in these things. These are considered pre-conscious behaviors. And so they are aware that we're still struggling with these things. But they honor our sovereignty. They want us to evolve, right? They want us to figure that out. They don't want to come in and tell us, you people are backwards, you shouldn't be doing this. They're not going to do that. They're helping us. So they do they have communication through star seeds, and they are, you know, trying to help us to evolve. And they do interfere with nuclear weapons. So whenever there's any kind of nuclear thing about to happen, they will interfere, because they can interfere in those cases, because if we detonate something nuclear, also this applies to CERN, by the way. If we detonate anything that has the capacity to interfere with other dimensions or other planets or other stellar systems, they can stop that, because we don't have that right. We can destroy ourselves if we want, but we don't have the right to destroy all of these other beings. And that includes the interdimensional beings that live on Earth. That includes the beings that live on Earth who are not human. We don't really have the right to destroy like millions of beings because we can't get along. We don't have that right. And so they will interfere when it comes to us doing that type of massive space-time destruction. And so when it comes to CERN, that's also presenting a risk to beings outside of Earth. And so I just got that just this week, that they are monitoring that as well. Okay. Oh, okay. Someone's giving us some information. Jed Stamus. Sorry, timestamps are negative. I don't know what that refers to. At one point, NASA says we know it came from a star with 64 kilometers per second relative velocity, older age, fits Talsag source of WOW signal toward the end of the conference. Oh, thank you, Jed. I did not catch that. So they actually mentioned the WOW signal, because I did hear them saying that they know it's from a very old star system because of something. So they identified the velocity. Now, how did they get the velocity if they don't know the mass? I'm just asking. That's like basic physics. So they must know. They must have used a mass to calculate that. And so you're saying that they did address the fact that one of the anomalies was that it seems to be coming from the direction of the WOW signal. So thanks for sharing that, because I didn't catch that. Okay. So thanks for that. And I'm just looking to see if there's any other questions that I missed. Thank you to everybody for watching, for liking, for commenting, for your gifts. I appreciate it. Oh, I didn't hear that. So LLC is saying that they heard them say on the live stream that May and July were dates. We're going to get data, I guess you're saying? That would be crazy. They first started collecting data in July of this year. Why would it take a year? Okay, this person, Dre24, said, I just came from Stefan's. He's talking about Stefan Burns, who's a geophysicist who's been covering 3iAtlas in his channel. And we laughed and laughed. They think we are idiots. We are getting a good laugh out of this, right? We got to be grateful for that. And that's one of the things I love about 3iAtlas is I've been doing all this heavy political work since, November of last year. And it's been nice to kind of take a break from the spiritual analysis of our political situation, the circus and everything that's being destroyed, right? And all the chaos and the suffering. It's been nice to take a break from that and talk about science and talk about aliens and talk about what if. It's been really fun. The energy is really light and bright, right? And so even watching this live stream, it is kind of funny, right? That they were like working so hard to not tell us anything. Oh. Oh my God. Okay. Okay, I'm just looking to see if there's anything else I should address before I close down this this lovely live stream. It's like I get on these live streams and they're so much fun. I don't want to leave. But then I look at the time and I'm like, oh my God, I've been in this live stream for so long. Is anyone going to want to watch for this long? I should probably close it down. And don't I have other work to do? But it's so fun. Oh, this is sweet. Look at this. Tomas Lacey Thomas. I lack the ability to contribute money. However, I'm grateful to be able to learn and grow in knowledge and spirituality with you, Dr. Lisa, and the beautiful community you are building. Thank you. Your presence is a gift. So, and your comment is a gift. So I appreciate you being here. I know everyone doesn't have money to give, but I do ask because my guides have insisted that I spend most of my time doing these videos and reading these comments and doing these live streams. And so much so that I don't have really a lot of time for my other sources of, for like sources of income. And so I feel like I have to, remind people to donate or whatever, so that I can feel like I can sustain this work that I really am meant to do. I want to sustain it. I'm doing it because I'm spiritually called to do it. And but the reality is I'm a human being and I have to pay my bills, and I live in Los Angeles, which is one of the most expensive places in the country. But I live here because for me, it's a very safe place to live. If you're, I'm a person of color, I'm a woman, I have, health issues, I'm gay, I'm a radical. Just puts a lot of targets on my back. And so living here, I feel very safe. California, Governor Newsom, he's really protecting us from a lot of the fallout from the circus. So this is a very safe place to live, and it's also very expensive. It's a trade-off, right? I chose to live here, but I chose to live here for some good reasons. And I'm just looking now to see if there's any other questions. Yes, we 4am folks are definitely a community. Uh-oh. Oh, this is my alarm telling me I got to go to the eye doctor. So I guess I'm out of time. But thank you, everybody. I hope I got all your questions answered. I think it was mostly just comments and just community and just laughter and outrage, right? We were just kind of sharing the outrage, which was awfully fun. So yeah, I'm going to continue to post about 3iAtlas. I'm going to continue to look for images and read papers and tune in and try to channel more new information as time goes on. So thank you, everybody, for being a part of this journey with me. It's been awesome. And everyone have a great day. Oh, wait, there's another donation. I have to acknowledge this person. Thank you so much. Barbara Blendy, very kind of you to send me this donation. I really do appreciate it. And why can't I figure that out? Okay, buy me a coffee. You can also buy me a coffee by taking a picture with your camera of this little QR code. Okay, good night, everybody.